Welcome to ChemDoodle Shorts. I'm Mary, your ChemDoodle Pro. Let's learn about alcohol, ether, epoxide, amine, and haloalkane functional groups. In organic chemistry, a functional group is a specific group of atoms in a molecule that has a characteristic chemical reactivity. It's used to predict a molecule's chemical behavior and to identify it through nomenclature. So let's learn about some simple functional groups that include heteroatoms, such as oxygen, nitrogen, and halogens. Let's begin with oxygen. One of the most common functional groups is alcohols. An alcohol has an OH, or hydroxyl group. The R represents an alkyl group. The alcohol that most people are familiar with that's consumed is ethanol, a 2-carbon alcohol with a terminal OH group at one end. Note the ending -ol to indicate an alcohol. Another basic functional group with an oxygen is ethers. An ether consists of an oxygen atom bonded to 2 alkyl or aryl groups. These R groups can be different, as seen here in anisole, or they can be the same, as seen in ethoxyethane. Ethers are often referred to by their common names. However, in IUPAC nomenclature, the alkoxy prefix is indicative of an ether functional group. A specific type of cyclic ether is epoxides. An epoxide is a 3-membered ring composed of an oxygen atom and 2 carbon atoms. Because of its ring strain, epoxides are highly reactive. The simplest epoxide is oxirane. Epoxides with additional short alkyl R groups can also be specified by oxirane in the name. Let's continue on with the simplest nitrogen-containing functional group, amines. An amine is made up of a nitrogen atom that is bonded to at least 1 alkyl or aryl group. In a primary amine, the nitrogen is attached to 1 alkyl or aryl group and 2 hydrogen atoms. Let's consider this amine. With a terminal NH2 amino group at the end of a 2-carbon chain, this molecule is a primary amine. In a secondary amine, the nitrogen is bonded to 2 alkyl or aryl groups and 1 hydrogen atom. In ethylamine, removing a hydrogen and adding a second alkyl chain now makes it a secondary amine. In a tertiary amine, the nitrogen is attached to 3 alkyl or aryl groups. In diethylamine, removing a hydrogen and adding a 3rd alkyl group makes this molecule a tertiary amine. Take note that amine in a molecule's name denotes an amine functional group. As you study chemistry, you may encounter yet another type of amine, a quaternary amine. In a quaternary amine, the nitrogen is bonded to 4 alkyl or aryl groups and carries a positive charge. It's also called a quaternary ammonium cation. In N-methyl diethylamine, adding another methyl group imparts a positive charge on the nitrogen and makes this molecule a quaternary amine. Let's continue on with the simplest halogen-containing functional group, haloalkanes, or alkyl halides. A haloalkane is comprised of a halogen bonded to an alkyl group. Recall that the halogens include fluorine, chlorine, bromine, and iodine. Let's consider this molecule. Fluoroethane is a haloalkane with a 2-carbon alkyl chain attached to a fluorine atom. Similar haloalkanes can be drawn with the other halogens. As seen with each of these, a haloalkane is designated by the appropriate halogen prefix in its nomenclature. You've learned that there are many basic functional groups simply with the addition of oxygen, nitrogen, or the halogens. Oxygen-containing functional groups include alcohols, ethers, and epoxides. Amines are made up of nitrogen, and haloalkanes consist of the halogens. Recognizing these functional groups will help you to understand a molecule's nomenclature and chemical behavior. Thanks for watching ChemDoodle Shorts.